Got a big robotics exam coming up? Yeah, I know. Units 3, 4, and 5 can feel like a lot. But don't worry, you are in the perfect spot. We're basically going to build a robot together, right here, right now. And by the end of this, you'll have everything you need to absolutely crush that test. So, let's get into it. Okay, so here's the game plan. Think of this as your secret weapon for the exam. We're not going to waste time on every little detail from the book. Nope. We're going to zero in on the big ideas, the core concepts that you absolutely, positively have to know. This is all about working smarter, not harder.
So here's how we're going to build our robot. First up, we'll put together the robot's body and brain. That's everything from Unit 3. Then, we'll install its senses so it can see and feel the world around it. That's all of Unit 4. After that, we'll teach it how to think, covering Unit 5. And to finish it all off, we'll run a quick systems check with a final exam booster, just to make sure you're totally ready to go.
All right, let's start building. You can't have a robot without a body, right? So Unit 3 is our foundation. We're talking about the actual physical hardware, the nuts and bolts that let it move, and the basic control system. It's kind of like its central nervous system. Let's dive in.
Okay, think of a robot's anatomy just like a human's. The manipulator? That's its arm, the part that reaches out. At the very end of that arm, you have the end effector, which is like its hand, holding whatever tool it needs. The actuators? Those are the muscles, providing all the power and movement. The controller is the brain, making all the decisions. And the sensors are, well, it senses, feeding information back to the brain. See? It's all one big interconnected system.
So how does a robot get its power? Well, it all depends on the job. For your exam, you really just need to know these three. Hydraulic systems use pressurized liquid for the really heavy-duty stuff. Think lifting cars. They're all about brute force. Pneumatic systems use compressed air for super fast, repetitive tasks, like you see on an assembly line. And then you have electronic systems, especially DC servo motors, which are the go-to for anything that needs insane precision, like building electronics.
Okay, listen up, because this concept is almost guaranteed to be on your exam, so let's nail it down. The single biggest difference between open-loop and closed-loop control comes down to one word: feedback. An open-loop system is like throwing a dart with your eyes closed. You just aim and hope for the best. But a closed-loop system, that's like throwing with your eyes wide open. You see where the dart is going, you adjust your aim, that's feedback. And that's why closed-loop systems are so much more accurate. So, quick recap for Unit 3. Remember, actuators are the muscles. Power transmission gets that power where it needs to go. DC servos are all about precision. The controller is the brain. And the number one concept to burn into your memory? Closed-loop control uses feedback for accuracy. Got it? Good. Let's give our robot some senses. All right, so our robot has a body and a basic brain, but it's basically just standing there, blind and deaf to the world. It's time to fix that. Unit 4 is all about giving it senses, the tools that let a robot actually perceive and interact with its environment. This is where things get really cool. Imagine a robot trying to pick up an egg. Without a sense of touch, it would probably just crush it, right? That's where tactile sensors come in. They give the robot's gripper the ability to feel what it's holding. It knows not to squeeze a light bulb too hard, but also not to let a heavy box slip. It's the robot's sense of touch, and it is absolutely vital for delicate tasks. Now, this is a super important distinction for your exam. A proximity sensor is simple. Think of the automatic door at a grocery store. It just needs to know, is something there? Yes or no? That's it. A range sensor, on the other hand, is like the parking sensor in your car. It doesn't just say something's there, it tells you exactly how far away you are. Both are essential for helping a robot move around without crashing into everything. Vision is probably a robot's most powerful sense, and here's how it works in 4 easy steps. First, the camera snaps a picture. Simple enough. Then it cleans up that picture, getting rid of any visual static or noise. Next, it looks for the outlines of all the objects. And finally, the really smart part, it figures out what those objects actually are. It's a logical flow from just seeing pixels to actually recognizing a part it needs to grab. And this builds perfectly on what we just talked about. Think of low-level vision as the robot's eyes. It does those first few steps, capturing, filtering, finding edges. It's just gathering raw data. But high-level vision, that's the visual brain. It takes all that data and actually interprets it. It's the difference between seeing a red square and understanding that's the emergency stop button. It's seeing versus understanding. Okay, our robot has a body and it has senses. But right now, it's just a puppet waiting for instructions.
It's time to give it a mind. Unit 5 is all about programming, giving our robot the intelligence and the instructions it needs to actually do stuff. This is where our creation finally comes to life.
So, there are three main ways you can teach a robot. The most hands-on way is lead through programming. You literally grab the robot's arm and physically guide it through a motion. A much safer way is offline programming, where you build and test the whole program on a computer first in a simulation. And the most powerful method is text-based programming, where you write code in special languages like KRL for KUKA robots or Rapid for ABB to create really complex, flexible tasks.
You hear the term AI thrown around all the time, right? But what does it really mean for robotics? It's actually really simple. AI is the thing that turns a robot from a puppet that just follows a script into a partner that can make its own decisions. That's it. That's the core idea. And you see AI in action everywhere. It's what lets a robot spot a faulty part on a conveyor belt or learn how to get better and better at a task over time. It's how warehouse bots can navigate a crowded floor without bumping into each other. Basically, AI gives robots the brain power to deal with the messy, unpredictable real world. All right, we've done it. We've built our robot. It has a body, it has senses, and it has a mind. Now it's time for one last systems check before the big exam. This is the final exam booster, a super fast review of the most critical stuff you need to know. Let's make sure you are 100% ready. Okay, for the written part of your exam, clear definitions are everything. So when you see the next slide, I want you to look at each term, hit pause in your head for a second, and try to define it out loud. Seriously, try it. Then we'll check your answers.
Okay, ready? Here are the top 5. An actuator is the robot's muscle. Closed-loop control is a system that uses feedback to fix its own mistakes. The end effector is the tool on the end of the arm. Image processing is how a robot sees and understands the world, and offline programming is building and testing the code in a simulation first. If you can define those 5, you're in great shape.
Now, for your oral exam, or VIVA, they love to ask comparison questions. The trick here is not to panic. Just focus on explaining the single biggest difference between two things. Let's practice with the most common ones.
Memorize this slide. Seriously, if they ask about open loop versus closed loop, the key difference is feedback. For hydraulic versus electric, it's the power source, liquid versus electricity. And for low-level versus high-level vision, it's all about interpretation, the difference between just processing an image and actually understanding it. Nail these 3 and you'll sound like a pro.
So, after all that, here's the one thing to remember. A robot isn't just a bunch of random parts. It's a complete, integrated system. The body from Unit 3, the senses from Unit 4, and the mind from Unit 5, they all have to work together perfectly. When you understand how they're all connected, you really understand robotics.
You made it. You now have a really solid grip on these core robotics concepts. So I'll just leave you with this one last question. Now that you know how they work, what's the one thing in your own life you wish a robot could just do for you? Think about it, because the answer to that question might just be the next big thing in robotics. Now go crush that exam. You've got this.